Hello, this is a tutorial on our project of ME366 Electromechanical System Design and Practice. We are group C7 and our project was automated cylinder column test. In the project, we mainly had two major tasks to accomplish. Firstly, continuous load was applied on cylinder column by a hydraulic cylinder, and secondly, the load was measured by a load cell. The data of load was then received by Arduino to do further processing and find the critical or buckling load of the cylinder column. We will go through how we managed to do these two tasks and the challenges we faced. For the first task, which is applying automatic continuous load, we used hydraulic components which are hydraulic cylinder, DC pump, ball valve, 5-2 directional control valve. This hydraulic cylinder was bought from Nawabpur. This is a double-acting hydraulic cylinder, which means that it can be both extended and retracted by fluid flow. It can withstand maximum of 1 megapascal pressure, which is more than we required. Then we had to select a suitable pump that would exert pressure in the working fluid, which would move the piston of cylinder. For our purpose, the maximum load required was much less than 10 kg force. At first, we used this submersible pump which we bought from Patuatoli. It is a pump with low power consumption and its pressure head is given 5 meter in its specifications. But considering the pressure loss in pipes, there was not enough pressure to exert required load on the cylinder column. So we replaced this pump with this diaphragm pump, which is much more powerful and provides more pressure. The power of the pump needed to be controlled according to our requirements, for which we used potentiometer and N-channel MOSFET. Apart from power, the flow rate of pump needed to be controlled as well because the loading rate depended on flow rate. For that we used a ball valve which regulates the flow rate. Next, we needed to control the direction of flow of fluid to either extend or retract the piston of cylinder. For that we used a 5-2 directional control valve. There are 5 ports in it and it can be set for 2 different directions. This was also bought from Nawabpur. We controlled the valve mechanically, which could also be controlled electrically with help of a solenoid. Now for the second task, which is measuring the load, we used a load cell with HX711 amplifier. At first we had bought a load cell from Patuatoli and connected it with Arduino, but the connection was not stable and the data we were getting was garbage. There were two possibilities. The wires of load cell are very delicate, and so exposing them too much to connect them with HX711 may have resulted in bad connection, or the load cell we bought had defects. So next we bought another load cell from electronics.com, a shop in Farmgate. This time we soldered the load cell wires directly to HX711 without further exposing the wires. This time the load cell worked perfectly. It should be kept in mind that the soldering are not strong connections, and if not handled carefully, the soldering will break apart, which happened in our case. We then needed to resolder again, and luckily for us it still worked. Also, we 3D printed these two parts to mount the load cell. Load cell works by strain gauges which need space to deform, so it should be kept in mind when designing these parts. M4 screws were used to join the 3D part and load cells together. We used HX711 library to calibrate and get data from load cell to Arduino. So this is it from us for this tutorial. Hopefully our findings and information may help you in some way. This was tutorial on automated cylinder column test.